Good morning, guys. There's Sangeeta here, your physics teacher. Okay, and we have finished around 2.5 hour of physics class. And I think and I hope you guys are happy with the videos I have uploaded. I know the only concern or only problem you might be having with me is I'm not showing your face, not showing you my face. Um, I feel very odd to show my face. That's why frankly speaking, I'm camera shy person. So I'm extremely sorry if you're feeling this much problem. Can't help it. I cannot fake smile, guys, for one stretch. I know you guys understand me. I hope so. Almost all the kids understand me. I try it. Uh, no, we made a lot of idle talks, right? So we'll talk a lot of things today also. Right. So, from where portion or which portion we stopped is last class? Oilic acid experiment, right? So, oilic acid experiment was done for measuring, or example for measuring a small distance, right? Now, that small distance was in very, very small, 10 to power, right? Minus values, right? That much small. So, now I'm going to introduce some of the terms, right, which you can use while terming or measuring a distance. See, what is 1 micron? This micro. You would have learned this mu, right? So you would write it as mu. Oh God, the pen is not writing. What happened to me today? Okay, see, it's not good luck. Okay, sorry. So 1 mu, 1 micron is equal to 10 to power minus 6 meter. This you know, right? Similarly, 1 nanometer is equal to 10 to power minus 9 meter, right? And what these two terms, you know. The new term, most of you, some of you guys might be knowing 1 Armstrong is equal to 10 to power minus 10 meter. This and all. See, if you see why I'm writing it, I will give you an example. Suppose you look, there is a value called 6.3 into 10 to power minus 10 meter. You can straight away write it as 6.3 Armstrong like that. See? So similarly, 1 Armstrong is equal to 10 to the power minus 10 meter. And 1 Fermi is equal to 10 to the power minus 15 meter. Right? Fermi and Armstrong. These might be the two new terms you have seen or heard for the first time. Right? So just like our light year, etc., I told you 1 Armstrong unit, etc. Similarly, for small distances, there is a value into the power base 10. We have some values: Armstrong, Fermi, nanometer, micron, and similarly, there are a lot of terms you have. I hope you guys are having your own textbook. If you guys don't have a textbook, you can download PDF files for each chapters, NCRT chapter. That is also available. If you want, you guys for me the link of PDF files, how to download it, you guys can write in the comment. I will give you the or send you the link. I don't think you guys are all techies. Anyways, so this much is regarding length. Now we'll talk with small portion, that is mass also. Now mass unit, almost all of you guys will just remember this a unit, kilogram. And along with it, you would have heard 1 ton, right? How much is 1 ton? 1,000 kilogram is 1 ton, right? Similarly, I hope you have heard 1 quintal, right? 1 quintal is 100 kilogram, right? So guys, I'm extremely sorry to term, in between I'm cutting off. See, you might be seeing I'm writing in two handwriting. It's my problem. Sometimes I write in a quite good handwriting, but sometimes when I write, it becomes a totally opposite handwriting. But I hope you understand from it. I'm the only person. I am the person who is writing the entire notes. Don't think someone else is writing. Okay. So 1 quintal is 100 kilogram. Similarly, 1 pound LB is equal to 0.45359237 kilogram. This should be called 37. I'm sorry. Right, and it is also in ounces. It is 16 ounces. Ounces you have seen, right? There will be a see whenever you are having Ayurveda medicine, the most disgusting, even if it is a good one, which is good for health, discuss taste. So you have a cup like that, or conical shape like that is an ounce cup, right? There you measure the medicine in ounces, right? Now similarly, there is one solar mass, and one solar mass is 2 into 10 to power 30 kilogram. You would understand what is one solar mass, mass of sun. So it is an approximate value, guys. No one has got used in which device you are going to use to weigh a sun. You can never measure it, right? So this is an approximate value, right? Now similarly, this might be a first time you are hearing Chandrasekhar limit, right? Chandrasekhar, it's our guy. Anyways, Chandrasekhar limit is 1.4 MO, and this MO indicates solar mass. Okay, right? Solar mass symbol is MO. So one Chandrasekhar limit is 1.4 what solar mass. See, this and all has just written in your textbook. I'm just giving an extra idea what a Chandrasekhar limit is. See, after a lot of years, the sun dies. I hope you know. After a lot of fusion process, at one end, the solar sun will be dying and it becomes a black hole, right? It collapses, right? The limit after which the sun has to attain this much mass, 1.4 times its own mass, so that it eventually becomes a black hole, right? That condition or that limit is known as Chandrasekhar limit, the limit at which the sun becomes a black hole, right? Now these are bigger mass quantities, right? A little bit bigger itself. Now we are going for a smaller mass unit, which is one unified atomic mass unit that you have learned in chemistry, 1 U. That is 1.66 into 10 to power minus 27 kilogram, right? Clear. Now, similarly, you have units of time. Please read this time, etc. portion in your textbook. I don't want to talk about how many days are there in your 1 year, how many hours are there in 1 day. This and all you can understand from just reading. Hey, please, guys. I am very lazy to take that part. Right? Now comes the hero of our portion, which is order of magnitude. Order of magnitude. See, okay, sorry, I'm babbling a lot. Anyways, what is order of magnitude? Actually, do you know this? What the procedure is, etc. But the term order of magnitude might be the first time you're hearing. See, I will just give you the proper definition of order of magnitude as your NCERT textbook. It is an approximate measure of number of digits that a number has in the commonly used base 10 number system. I hope you didn't understand anything. I'm going to read it again. An approximate measure of number of digits that a number has in commonly used base 10 number system. Base 10 number system, that is a bigger thing. I hope you know what is base 10 number system. 10 to raise to x, this is base 10 number system. That is, in layman language, writing a number as a multiple of 10 to power something. See, this is clear now. So I'll give an example. I am having a number 1. How can I write 1? I can write it as 1.0 into 10 to power 1. No, 0, sorry. 10 to power 0 because 10 to power then the order of magnitude is equal to 0. I'm extremely sorry, guys. 1 can be written as 1.0 into 10 to power 0. So the order of magnitude, right? This 10 to power x, that x is 0. So the order of magnitude is 0. Similarly, 1, 2, 3. Always put decimal after the first digit. So 1.23 into 10 to power how much? 2, right? Right, 100. 100 means 2 places goes on to left of the decimal. So the order of don't write it as OM, okay? Ohm. I'm just writing here before, not because I'm lazy. Okay, the order of magnitude is 2. This much clear. Now let's make a bigger number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? How would you write it in the scientific notation? You will write it as 1.2, 3, 4, 5, 6, 7, 8, 9 into how many places has to come here? 1, 2, 3, 4, 5, 6, 8. Right? So 10 to power 8. So the order of magnitude is 8. This much clear? Now, why am I doing this much tedious job? Why should I do? See, yes, I understood you can reduce the space. Where are you reducing the space? I don't see as any reduction in space. I can say only the increase in space. I could write 1, 2, 3 in small portion. When I put 10 to power 2, it is a bigger portion. So that scenario goes off. So why am I doing this? See, if when someone says a number and he says that the order of magnitude is 0, see, someone is saying that I have a number with me and its order of magnitude is 0. Then you can straight away understand that that number which he is, keeping in his mind is very close to 1. Now, similarly, if a person says, I have a number in my mind, its order of magnitude is 2, then I can straight away say that that number is very close to 3-digit number, which is 100. Clear? Right. So suddenly another person says, I have a number in my mind. The order of magnitude is 1. Right. That means 10 to power 1. Right. Put that word. The 10 to power 1 means 10. So I can say the number is close to 10. Right. Order of magnitude 0. Number close to 1. Order of magnitude 1. Close to 1. Order of magnitude 2 close to 10 to the power 2, that is 100. So similarly, if a person say order of magnitude is 4, that means the said number which the person or your friend is having in his mind is close to how many zeros? Right? 4 zeros. I hope this much is clear. Right? Right. So you get an idea how much is a number close to by just looking at the order of magnitude. That means all of them, you don't get the particular digits as it is. You will get an idea between 100 and 1000 like that. Right. Now, let's see. We'll take some more examples. I hope this much is clear, guys. You are having a number 100. How can I write it in the scientific notation? 1.00 into 10 to the power 2. So the order of magnitude is again 2. See, the order of magnitude is 2. Right, just like the previous case, order of magnitude if happens to be 2, the number is close to 100 like that, right? So, how would you write 999? You will write it as, how? 9.99 into 10 to the power 2. Right? So again, order of magnitude will be 2. This is what you will think. Right? Now the problem comes up. See, why we are learning order of magnitude gives you an idea to which number the number which you are having is close to. Now let me ask you a simple question. 999. 999 is close to 100 or is it close to 1000? For me, it is close to 1000. Right? And what is thousands order of magnitude, guys? 1,000 into 10 to the power 3, right? So the order of magnitude is 3, right? So that means order of magnitude of 999 in place of 2, it is 3. Right? I hope you understood. We have just started. Right? So you have to look at the number also. Right? Right? This is, I have not touched the decimal part, guys. I'm just giving you an introduction of order of magnitude. I hope you understood. Triple, and similarly, you're having a number 997. Which number it is close to? 100 or 1000? It is close to 1000. What is the order of magnitude of 1000? It is 3. So 997 will be also having order of magnitude of 3. So how would you write it as 9? That we will be written as 0.997 into 10 to the power 3. You are supposed to write it like this, not like 9.97 into 10 to the power 3. This is scientific notation, guys. You as a layman, you can write it as 9.97 into 10 to the power 2. But a scientist or a person who is very keen in physics, this is the way he is supposed to write in a scientific notation. Clear? Because you would have seen in many textbooks and myth books, and you would have thought why these numbers, that is 997, is not written as 9.97, it is written as 0.997 into 10 to the power 3. That is, see, mathematically, I'm not talking about scientifically, mathematically, 9.97 into 10 to power 2 and 0.997 into 10 to power 3, both of them are same value, right? Mathematically, these two values are same. But scientific notation, there is a rule to look to the number or the closest number, and the number will have the same order of magnitude as that of the closest number. Clear? Now why we are taking this 10 to power thing, or 10 to power base, or 10 base values, when I can use 0, 10, 20 like this? See, the problem is there are two types of line system. I'm just telling you guys, this is not there in your NCERT textbook. I just want to give you an idea, right? So see, if there is a line system, I'm taking this as 0, this is 10, 20 like that, and it goes off to 50 say, right? And this system is known as your linear system, right? Now there is a system called log system. I don't know if you have start learning logarithm, guys. So 10 to power 0, 10 to power 1, 10 to power 2 like this, and let's say it is 10 to power 5, so 3, and this is 10 to power 4, right? This is a system, and let's say this, and this is log system, and say both of them are in kilometer. All right, now I can say I have a friend, and that friend is around 20 kilometers away from my home. I can easily say that in this scale, right? I can, right? But if the scale can be used, will the scale can be used for measuring a distance from Kerala to, let's say, Jammu? No, I don't think so, because 50 kilometer can be only measure. But can I give that measurement in this scale, log scale? Obviously, right? So longer distances as well as shorter distances, right? See, suppose 20 kilometer, right? 20 kilometer means it is 10 kilometer hour, then 20 kilometer will be quite close to this one, right? So that is, this is 10, sorry, this is 1, right? I'm sorry guys, this is 10 and this is actually 100. So 20 kilometer will be in this region. I can get an idea, right? So log scale can be used for both smaller distances as well as larger distances, whereas a linear scale, it is very difficult for, see, you have your own length, you can measure with a meter strip, right? But if you have another person over your head, how are you supposed to measure with a meter strip? It's very difficult. Yeah, so that's why for longer distances we are using a 10 to power base scales. Right, this is just a big idea why we are doing so. This much clear? Now we are going to the basic section from where the numerical questions for this chapter comes up in both the NEET examination, JEE, but for last some of the years they have not asked, but who can say what can happen in the future, right guys? So we are for taking the first example. See, there is a number 4980, right? What is it? 4980, and you're asked to write this number. Either they will be asking you guys to write in scientific notation, or you will be asked to write the order of magnitude directly, right? Two ways the questions can be there. So what is the first step? What did I ask you guys to do? Put a decimal after the first digit. 4.980 into 10 to power 3, right? Now listen to the rule, guys. Always look at the first digit, right? The first one, 4, right? Now this digit, or the first digit that is in the left position of the decimal, if it is greater than 5, then always put, if this is the order of magnitude, put a +1 to it. Clear? I will give an example, right? Now, if the first digit in the leftmost position, right, of the decimal, if it is less than 5, put that value of the order of magnitude as it is. I hope you didn't understand. I will give this example, right? Let's see. 4. Look whether it is greater than 5 or less than 5. It is less than 5. So, no change, guys. You can straight away write the order of magnitude is 3. Right. Let's put another value, 6.980. Sorry, oh shit, don't put 6, I curse now, sorry guys, 6980, Right, that is our next question. I am going for the next, guys. Let's say we are taking 6980 and you are writing it in what numerical section or scientific notation. How would you write? 6, after that put a decimal, then 980. Right, now 6.980 and then I will put 10 to power how much? 3. This much clear? Now look at this value 6. Now 6 is greater than 5 or less than 5? It is greater than 5. So what should I do? With this 3 I am going to add 1. So that now the order of magnitude is 4. This much clear? Simple, right? So always look at the first digit. If it is greater than 5, add plus 1. If it is less than 5, no change. Now the problem comes. What the first digit is 5 itself. That is equal to 5. Let's take an example. 5200. So how would you write? You will write it as 5.200 into 10 to the power 3. Simple as it is. Now comes the problem. Right, how would I write? Because it is neither greater than 5 or less than 5. Listen guys. So 5200, right? I'm going to write two extremities in tens. It is, see, 5200. So two extremities means 1000 and 10,000. This number is in between these two extremities. That is, I can say 10 to the power 3 and 10 to the power 4 in between these two extremities. This much clear? Right. Now let me ask you another question. 5200, whether it is close to this value or if this close to this value. Any person can say 5200 is close to this value, right? If it was 5000, it is exactly between 1000 and 10,000. 5200 is closer to 10,000. So which order I am supposed to take? This order. That means the answer of this one, that is order of magnitude, is 4. Clear? Let's take some more examples. Right? Okay. Which one? Okay. Let's say 6218. Did I do the same question? I don't know why this number comes up. Anyway, so what will we do? You will write 6.21896 and you have 5 places to come up. So it is 10 to the power 5. 6 greater than 5. So the order of magnitude is 5 plus 1, that is 6. Heights. Answer that. Right? 3.21896. 3.21896 into 10 to the power 5. Again 5 places, right? So but 3 is less than 5, so order of magnitude as it is, this is 5. Right? Now let's do a googly, as you say in cricket. Right? Suppose you are given a value like this, 0.008. How would you write this one in scientific notation, guys? First, a digit has to be in the left side, right? So I will write it as 8.00 into 10 to the power. Oh, my dog is barking like anything. Okay, after writing this much, what can I say? Again, I will look at 8. Is it greater than 5? Yes, it is greater than 5. So I will take this minus 3. I will add 1 to it, just like the previous case. And what it is? Minus 2, right? So what is the order of magnitude here? Order of magnitude is minus 2. Let's do another example. 0.003. How would I write it? I write it as 300 or 00, 10 to the power minus 3, 3 less than 5. So you will write the order of magnitude as it is, that is minus 3. I hope this much is clear, guys. Now next, actually the topic was errors. But before we go to the what error is, what type of errors you have to learn. Error, I hope you understand, right? Which we always make in your examination. Error, careless mistakes, right? So error means something under uncertainty which is coming in calculation. That is your error. right? So before moving to that portion, you have to understand two terms. So by that two terms we'll finish today's video, okay, today's class. So that is accuracy and precision. Accuracy and precision. Till 11th class, for you guys, accuracy and precision were quite similar terms. But since you have reached physics and you are studying in 11th class, you have to understand there is wide difference between what an accuracy is and what precision is. See, and both of them is regarding measurement of any quantity, okay? Now say, how can we make you understand? Okay, first we will tell what is the definition. Accuracy, this definition is, accuracy is how close a measured value is to the actual value, right? Whereas precision is how close the measured values are to each other. I hope you didn't understand anything. Now first you have to understand what is actual value and measured value, right? See, suppose a company has released that this weight is having a weight of 1.25 kilogram for sure. It's released by the company, right? So they are telling this weight is 1.25 kilogram, means damn sure it is weight, or I can say it's true weight or actual weight is how much? 1.25 kilogram, right? So that is your true weight. Now what did I have? I had another measuring gauge and I'm going to weigh this 1.25 kilogram actual weight object, but I found that the readings were quite different. First this gauge gave me 1.23 kilogram, it showed 1.23 kilogram, then it showed 1.24 kilogram, suddenly it showed 1.28 kilogram. 3 readings, man, and 3 of them are not actually 1 point. If that gauge had shown 1.25 kilogram, I would have been happy, right? So this is how you usually do in physics or any lab, right? You take 2 or 3 readings and you usually take average. That and all will come up. But yes, you have a light idea. So when you took these 3 readings, so the weight of this object, which was 1.23, 1.24, 1.28. Now let's move on to the accuracy's definition, guys. Accuracy is how close is the measured value. This is your measured value. You measured it, right? How much close the measured value is to the actual value, right? Or true value, as in. So tell me which one is very close to the actual value. 1.24 is truly or very close to 1.25 close. So that means 1.24 is the accurate measurement. Clear? Neither 1.23, neither 1.28. I can say 1.24 is an accurate measurement. This much clear? Now the next hero comes up, precision. Let's say the same weighing gauge, okay, or same weight I'm going to measure. I had 2 weighing gauges. Let's say this one is first weighing gauge. See, I'm very lazy, that's why. Okay, this is the first weighing gauge which I had, and my brother had another weighing gauge and he measured the value. See, just 1.24 kilogram. Then it had 1.25 kilogram, and then it had 1.26 kilogram. See, this is the measurement you were taken by my brother or your brother whatsoever. So when he when he found, see the difference, 1.01, 0.01, right? Precision is how close the measured values are to each other. See, the difference here is 0.01, here also is 0.01. So the measured values are quite close to each other and are in significantly same difference. Whereas let's see here it is 0.01, but here it is 0.04. See, so the difference is not consistent, right? So I will say these 3 values or these 3 measurement is precise. Or I can say my brother gave the precise measurements, whereas I gave wrong measurements, right? Whereas my measurements, out of my measurements, 1.24 kilogram, this measurement is actually close to the actual weight. Hence, according to my measuring device, 1.24 is what is the
accurate measurement. So out of my brother's reading, which is accurate measurement, 1.25 is the accurate measurement. This much clear, right? This is the difference, guys. Clear? Now let's take a simple example. I will make you guys much more easily understood. See, this is a very good example. See, this is my aiming board. That means the shaded portion, right? That is my true value or actual value. And this red balls indicates the reading which I have taken. Now here see, all the readings, which is the red balls, are quite near to the actual value. So that means which is high accuracy. So higher accuracy. So if the readings are close to the true value, higher accuracy. Right. Now similarly, they are all equidistant from each other. Even if the diagram is not looking so, I expected to make them equidistant. So that means each readings are equidistant from each other, means high precise. Similarly, look into this figure, saying the true value, all the readings are close to the true value, means they are highly accurate measurement. But see, each measurement is not equidistant, they are at random position. That means precision is low. Now let's take then another example figure. See the same figure, but no values is close to the actual value, means low accuracy. Whereas each measurement is quite close to each other, right? That means high precision. I hope you understood with this figure, guys. I am not writing the values because decimal values, if you are written, I don't think you guys are going to understand, right? So again, I am repeating the values, if they are close to the actual value means if the measurement is close to the actual value, high accuracy. If each measurements are equidistant from each other, that means high precision. Clear? Okay guys, please listen to the video again and again if you are not understanding any concept. Okay, bye.